Hello. So this is my last video that I made on Naïve Bayes, where we conceptually went through Naïve Bayes' working mechanism with some math and probabilities. And in today's video, we will be implementing Naïve Bayes in Python, and we'll start by creating a data set, and we will run through each and every calculation. So by the end of today's video, we're gonna have a very good grasp on math and as well as on code. So let's buckle up and get started. So I have a notebook ready to implement Naïve Bayes. And in the last video, we looked at customer behavior, whether they clicked on an image, stayed for more than 2 minutes, added an item to the cart, or read the reviews. And we used Naïve Bayes to classify whether a new customer will buy a product or not based on the new customer's behavior. So let's do that, and we will start by creating a data set. So let's get it. First, we'll import pandas and create our data. For this demo, we have 10 users. We'll just make 10 users. And the first feature of our user is clicked image. The second one is stayed more than 2 minutes. The third one is add to cart. The fourth one is rate the reviews. And finally, we have our column by, which is either yes or no. All right, so now let's populate our data set. And I've already populated the data, so time to change our data into pandas data frame so that we have an easy time manipulating our data frame later. All right, so let's name it df. And print top 5 rows. All right, so this is our data. We have total 10 rows, but for now we're just printing top 5 rows. And if you see second customer, then the second customer clicked an image, didn't stay for more than 2 minutes, added an item to the cart, didn't read the reviews, and finally decided to not buy the product. So this is how the data set is, right? As we can see, we have categorical data, so which means either we have yes or no, and we also know that Naïve Bayes doesn't work with categorical data. So we will be changing our categorical data into numerical values. So let's do it. So we'll be replacing yes with 1 and no with 0. And after this replacement, let's go ahead and print top 5 rows. So this is pretty much clear, like why we're doing this, right? Because we know that when we do further mathematical calculation, we need numbers, not categories. And now we have a numeric data set ready, so we will go ahead and find prior probabilities. So the first prior probability would be the probability of a customer buying a product, which is basically the total number of customers who have bought the product divided by total number of customers we have. So let's go ahead and do it. So the shape 0 gives us the total number of rows, where by column has value 1, and we'll divide it by total number of customers, which is df.shape 0. And the next prior probability is the probability of a customer not buying a product, which is basically 1 minus probability of a customer buying the product. And if we go ahead and print, all right, so we can see the fraction of the customers who have bought the product is 0.6, which is also probability of a customer buying a product. And similarly, the probability of a customer not buying a product is zero point 0.4, just 1 minus 0 0.6, right? So with this, we've calculated prior probabilities. After prior probabilities, now we have to find likelihood. So to be very short and concise, likelihood represents the probability of seeing a particular feature given a specific glance. So imagine in this case of an online store, we will be able to answer questions like, given that the customer bought the product, how often did they also click the image? Or maybe, given that the customer has not bought the product, how often did they read reviews? So likelihood helps us answer all those questions. So let's go ahead and calculate likelihood. For that, we'll split our data frame df into two data frames. The first one is df buyers, where we will only include customers who have bought the product. Similarly, we have non-buyers. Zero. So after that, we have separated buyers from non-buyers. Now this is the time that we find the likelihood of the features given that the customers have bought the product. So this is calculating feature likelihoods for buyers. And similarly, we'll find feature likelihoods for non-buyers. And let's go ahead and print. Likelihood of the features among buyers. And the similar print statement for non-buyers. All right, so let's print it. All right, so we can see that we have likelihood of each of the features, and we can see the likelihood of the features among buyers. So among all the buyers that we have in our data set, the probability that they will click an image is 0.13889. And similarly, out of all the non-buyers that we have in our data set, the probability that they will read the review is 0.1250. So I hope that is clear, because it's important to know what likelihood exactly is before we move ahead and find posterior probability. Time to create a new customer, and we'll be creating the same customer that we had in our last video. So let me just copy this code. So we only have one new customer, and this value is 1. You can see it. And the customer hasn't stayed for more than 2 minutes. And also the customer didn't add to the cart, but the customer did read the reviews. And let's rename the customer and change it to data frame. And print it. And we don't have this column at all, because that's the one that we're trying to find through posterior probability. So this is our new customer. And so finally, we will be computing posterior probabilities. And if you see in this Bayes theorem, we won't be considering denominator at all, because this doesn't make any difference, as we've already talked that this is a constant. So we will be only focusing on the numerator part. So let's create a variable posterior by, which is essentially the product of two terms. The first one is prior probability, and the second is likelihood. Let me copy the feature names so that I don't make any mistake. For For the second feature, we see that the customer hasn't stayed for more than 2 minutes. That's why we have to do 1 minus the likelihood of a customer staying for more than 2 minutes when the customer has bought the product. And the case is the same with the third feature as well, add to cart, because the customer hasn't added an item to the cart. And finally, we have fourth feature, which is read the reviews. So this expression gives us the posterior probability of a customer buying the product, and we have to similarly find the posterior probability of a customer not buying a product, which can be easily found by replacing buy with non-buy. I hope I haven't made any mistake. Yeah. So yeah, this is wrong. So let's print. Posterior buy, and finally we'll be printing for the posterior probability of customer not buying. Okay, so these are the values. The posterior probability of the customer buying the product, which is 0.007, is greater than the posterior probability of the customer not buying the product, which is 0.002. And so we classify that the customer will buy the product. And this as a whole is the simplest implementation of Naïve Bayes I think you can ever imagine. And if you want to know more why is it called naive and why that Bayes word is there, just go and check out my last video. I have explained everything in a very detailed way. And if you found this video useful, then make sure to subscribe and let me know if there's any topic in particular you want to learn about. I'll try to include that in the next video. Until then, bye bye.